So here we go on a brief overview of epidemiology. And I just want to start by saying that if there was ever a piece of public health practice that is at the forefront of our lives right now, epidemiology, or as we often call it, epi, is where it's at. So there is a lot of meat that I'm providing to you outside of this lecture today. Um, so get ready to just kind of dive into the whole world of epidemiology and what it has to tell us, how it informs our practice, what it has to tell us as public health professionals. So I'm going to skip through real quickly the first few slides because these are things that are easily readable and explainable on your own. But this basically tells you a little bit about what epidemiology is. It's the basic science behind what we do in public health. Epidemiologists ask these 5 questions: who, what, when, where, and why. We'll get into some application in a minute. Where does this fall on the wheel? I told you I would continue bringing up the wheel to you. So where this falls on here is monitoring health when we are just doing general surveillance and understanding what diseases are out there in the community, and then diagnosing and investigating when we are actually doing what is happening right now, where we are investigating positive COVID cases, understanding, doing contact tracing where we make contact with all the different possible exposures they've had, different places, different people. That's a big piece of what we do in the diagnose and investigate category of our public health essential services. So I have 2 key figures. I always think it's important to understand our history and the context for where we are in whatever aspect of public health we're talking about. So I would like for you just to click on John Snow's link here, and then Florence Nightingale, where you can learn a little bit about these 2 individuals and what roles they had to play in furthering epidemiology as a science that actually dictates our practice today. John Snow's story, I think, is especially fascinating, and so it's a quick read. I just want you to hop on and learn more about him there. Again, these are just basic definitions that I will let you read on your own, and then we'll get into some application in a minute. This is a video. I will also link it on Canvas, but I really, really want you to watch it. It's about 6 minutes, and it's just an excellent description of the difference between incidence and prevalence. These are major epidemiological terms that I want you to be very familiar with and understand how to calculate these rates. And so this video does a great job of explaining it. Usually my students will say that they watched this video several times to make sure that they really got it. So I encourage you to do the same. Additional measurements that I want you to be aware of, and this has especially come to the forefront when we talk about COVID-19, is R naught. And this is basically a mathematical number that quantifies how contagious a disease is, how quickly it's able to reproduce and infect others. And so I have linked a video for you. It's linked here, and then it's also will just be linked in your general readings for the week, because it's an 8-minute video where a scientist from Yale goes through on a whiteboard and explains just a vast array of topics related to our COVID pandemic. And in there, towards the very end, she explains how you calculate R naught, and how the greater the number, the scarier that disease is, because it can spread rapidly to more people. Incubation period is another really important concept to understand in epidemiology, and this is basically the time period between when a person is first exposed to an infectious disease and then the time that they first have symptoms. So if the incubation period is short, that is helpful for us, because it means that if you've been infected, you don't have to wait very long before you know if you're actually going to get symptoms and actually progress with the disease. And so you'll know that quickly, and then your actions can be, if you can kind of decide if you want to, if you're free from infection more quickly so that you can resume normal life. As with COVID-19, as you may well be aware, the incubation period is estimated to be anywhere from 2 to 14 days. 14 days is a long time. So this means that you could potentially have been exposed to the coronavirus and then not develop symptoms for a full 14 days. What that means, practically speaking, as you also may know, is that then in order to see if you're going to develop the disease, you have to wait 14 days and self-quarantine so that you don't infect anyone else asymptomatically while you're waiting to see if you actually get it. Other terms that may be familiar to you already are epidemic, pandemic, and endemic. So a few years ago in San Diego, we experienced the hepatitis A epidemic. And the reason that we called it an epidemic wasn't because we hit a certain number, a certain cutoff, but it was because all of a sudden, Hep A was affecting a much greater percentage of the population than what we were historically used to. So it's all about norms, and there are not specific formulas or cutoffs for this. But if you want to easily find Hep A graphs for San Diego County, you can do that on our county website, and you can see how our rates were very, very low, and then all of a sudden just skyrocketed in 2017. A pandemic is something obviously that we're in now. Again, there's no hard line definition for this, but it is something that becomes worldwide in distribution. And I was actually surprised at how long it took the World Health Organization to name this a pandemic. It wasn't until mid-March that they came out and named it as such, even though it had been spreading globally and we'd seen community transmission for several months before that. Endemic is something that is usually always present in a certain geographic area or with a certain population. So an example of something that is endemic is malaria in parts of Africa. We would just say that malaria is endemic to Africa because it is always present there. So this is a very basic model that we use in epidemiology to kind of wrap our heads around a certain disease and kind of the key things we need to know about it. So if we use COVID as an example, we first think about what is the disease. Well, the disease is COVID-19, right? That's what we've called it. The host is usually us, but we do know that it did come, well, we believe that it came from bats before it got to humans, but now we are the main hosts. We also have learned that it can be transferred to cats and dogs as well. The agent is the novel coronavirus, right? So the scientific name for this virus is SARS-CoV-2 because there are plenty of other coronaviruses out there. So this is the name that we've given this specific coronavirus. So we know it's a virus and that if it progresses to a disease, it's called COVID-19. And the environment. So this is when we think about, okay, we need a host, we need an agent. What's the environment that allows for this transmission and infection of host to occur? So I'm going to let you kind of think about that for a minute, but do we know anything about the climate? My hunch is, the science is not out yet on that. It looks like it's hitting everywhere in the world. How does housing affect the transmission or the infection? And I bet you can answer that. How do healthcare settings affect that? Does travel affect that? And I think we are really seeing how our global society, how interconnected we are, has greatly affected the spread of COVID-19 in this pandemic. So these are all things to consider as you look at the epidemiology of a certain disease condition. So now I just want to go into the application piece. What's the big deal with epidemiology? It should, as with any other kind of science or research, inform what we do. It should be telling us who is at greatest risk, what is this thing that we're dealing with, when is it occurring more frequently, how can we slow that spread, where is it occurring, are there more geographic regions or populations that are at higher risk for this spread, and why is it happening? What other conditions are playing into this spread and the fatality rates or mortality rates? So when we think about prevalence, so this is a number of cases of the disease that are currently present in a population at a specified time. And to make it a rate or a ratio, it's just making it a fraction. So you would give the top number would be the number of current cases, the bottom number would be those who are at risk of having the disease. So I want to know, what is the prevalence rate? And you might be helpful for you to pause this with a pen and paper. What is the prevalence rate if there are currently 2,153 coronavirus cases in San Diego County right now? And I am speaking at the end of May. So this is an estimated number. We don't have accurate data on actual cases. We have data on total number of cases and number per day, but not actual cases that are currently still happening right now, still infected people. But let's say that this is the number of current cases. So what would our rate be? And you may be wondering, well, I need some more information. The information that is missing is the total number of the population, right? So that would be your denominator. Who are the people that are at risk? And I can tell you that our county is estimated population is just over 3 million. So you can use just straight 3 million as your denominator. And you should eventually get this answer if you divide the denominator by the numerator, which is 2,153, and then you multiply that by 1,000. We usually have to do that, otherwise these numbers are incredibly small. And so your answer is 0.72 people per 1,000 is our current prevalence rate in San Diego County. Remember, this number is made up, this prevalence number. Now, if we talk about the incidence rate, that's looking at new cases at any given point. Okay, so let's say that we have 96 new cases of coronavirus on May 24th. This actually is a real number. I'll show you the graph in a second from the county. 96 cases were identified on May 24th. And then we need to put a denominator. Now, what is the denominator? It's the number of persons still at risk. So the tricky part here is it's not 3 million because we already know that there's 2,153 people who have it already. So they're not at risk anymore because they already have it. So then what you're doing is you're doing 3 million minus those who already have it as the denominator, and then the numerator is 96. And you should get this answer, 0.03 per 1,000 per day. That is our incidence rate for the day of May 24th. Here's the data actually from the county. And so this shows you in blue the total number of cases for that day. That's going to continue to increase because they're not able to accurately identify who no longer has COVID, right? So that number will always be going up. And then the yellow cases are new cases. And so you can see our incidence rate has kind of fluctuated on and off. This is probably not the most helpful graph when we look at things like flattening the curve, which I want you to be exploring for your discussion board this week. But this is helpful in just seeing basic prevalence and incidence rates for our county. So my final question for you here is, and these are real numbers. I have the date range for you here. The county started collecting these numbers on February 14th, and the last that they've posted as of this lecture recording is May 25th. So if you add up the number of new cases, which is 96, to the number of existing cases that I gave you, that was the fictional number of 2,153, that does not give you this total number here. And this total number is accurate, total number of 6,797. So why is there a gap? That's about a 4,000 person gap between the total number of cases and the current number of cases. And so what I'm asking you here is, what causes prevalence to drop? And if you've watched that video on incidence and prevalence, you'll know that there are two answers to this. And the answers are death or cure. We can see that there's 249 deaths, so that would help close that gap between total number and current number a little bit, but 249 is not even close to coming up with that 4,000 person gap. And so we could say that perhaps the rest have recovered, right? So that would be our answer, is that the rest have recovered. Now, again, we don't have accurate recovery numbers in the county, but that would be the other reason besides death is cure. This hospitalization and these death numbers and current case numbers are accurate. And you can click this link here to see the actual county data. So that's where I come up with the answers to the question that I just asked you. So that is all I have for you on epidemiology. I look forward to engaging with you more in our discussion, and there's a lot of great videos and things that I have for you as well.